Okay, here we are again, and today we're going to talk about transformations. We're going to focus on two specific types of transformations. We're going to look at shifting left to right, up, down. You caught that? That was up, down, right? And left, right. And we're also going to look at reflections, both over the y-axis and over the x-axis. So let's start with shifting. What can we look for in an equation to show that the whole graph of the equation is going to shift up or down? Okay, that's what we're going to talk about first. So let's say that we're going to call this function here f of x. If we wanted to take that whole function and shift it up, we're just going to add a constant after the function. Okay, for example, if I wanted to take this whole thing and shift it up 2 units, I would say that that would be f of x plus 2. Okay, so whatever the function is, we're going to take it and shift it up 2 units. So this is going to be up 2 units. Okay, if I wanted to do f of x minus 3, that would be shifting down 3 units. Okay, so we're going to take one of these and actually graph it on this coordinate plane. Let's take, let's do this one. Let's do this one right here. We're going to take f of x and take this and shift it down 3 units. That means every point on this graph is going to go down. So this point over here at negative 4, 0 is going to go down 3 units. 1, 2, 3, 4. So we're going to go down 1, 2, 3 units, okay? And that's going to be this one. Now this point negative 2, negative 2, negative 2, negative 2 is going to go down 3 units. 1, 2, 3 units. This point here at 0, 0 is going down 3 units. 1, 2, 3. This point here at 2, 2 is going down 3 units. 1, 2, 3. And this point here at positive 4, 0 is going down 3 units. 1, 2, 3. Okay, so now we can take those and connect the dots. And we have our transformed graph. Okay? So we're taking this and turning it into this. This also holds true if you've got one of our many parent functions. Let's say I had f of x is equal to x squared. Well, we know that's a parabola with a vertex at the origin. If I wanted to shift it up or down, I would just add or subtract a constant value. So plus 1, minus 5, whatever. Okay, we could do that with absolute value. We could do that with a linear function, whatever we wanted to do. Okay? So that takes care of up and down. So now we want to talk about left and right. Let's come over here, and we're going to, instead of adding and subtracting outside the function, to shift left and right, we're going to add or subtract inside the function. So if I wanted to do this, this would be a shift 3 units to the left, okay? And that's a little bit counterintuitive, but if I take this x plus 3 and set it equal to 0, x is equal to negative 3, this tells me we're going 3 units to the left, okay? And likewise, if we did like f of x minus 2, that would be, let's solve for x. X equals 2 units in the positive direction to the right, okay? So again, let's take one of these graphs and plot it. Let's do this one. And we're going to take each one of those points and shift it 2 units to the right, okay? So we're going to start here with our original graph at 1, 2, 3, 4. We're going to move it, that's actually 3, so we want to go to 4. Move it 2 units to the right. There's that. Negative 2, 2 is going 2 units to the right. 0, 0 is going 2 units to the right. 2, 2 is going 2 units to the right, and our last one, 4, 0 is going 2 units to the right, and then I just connect my dots, I'm good to go. Okay, so we're going to continue on with our discussion on transformations with a little bit of a dialogue about reflections. If I am looking at the axes here, our coordinate plane, we have two axes. We got the y-axis and the x-axis, and I can reflect pretty easily this graph over either one of them. You can also reflect over other lines, but we're going to talk about today is how to reflect over the x and y axes. And it's really very easy. All we're going to do is we're going to add a negative. We're going to negate some values, okay? So we are going to take, if we want to reflect this over the x-axis, in other words, we're going to flip it up over that x-axis, what our function is going to do, if our function was initially y equals f of x, our new function would be y is equal to negative f of x. And this is going to take all those y values and negate them. So a negative 2 in the y position would become a positive 2. A positive 5 in the y position would become a negative 5. Okay, and I'll talk more about that in a second. But what this does is flips or reflects over the x-axis. Okay, so let's take this graph and apply this transformation. So let's look at the first coordinate here at negative 5, 0, and I'm going to take this coordinate, negative 5, 0, and negate the y coordinate. Okay, well, what is the y coordinate? It's 0. If I make 0 negative, it's still 0. There's no such thing as a negative 0, right? It's just 0. Okay, so now let's look at another coordinate. Negative 2, 1, 2, 3, 4. Negative 2, 1, 2, 3, 4. Okay, so here is our original coordinate, negative 2, positive 4. I'm sorry, negative 4. So take that y coordinate and negate it. Make it the opposite sign. So negative 2, negative 4 would become negative 2, positive 4. All right? Let's come over here to we've got 2, negative 1, 2, negative 1. So here 2, negative 1. We're going to reflect it over the x-axis, which means this is going to become 2, positive 1. Okay, so 2, positive 1. And then the last point here is 1, 2, 3, 4, 5, negative 1. 5, negative 1. Okay, let's reflect it. 5, negative 1. Take that y coordinate and flip it. Okay, so 5, negative 1 becomes 5, positive 1. And then if we connect our dots, we have, we have a graph that, oh boy, I graphed 6, negative 1. That looks like I just took this and folded it up over the x-axis. So that's what happens when you put a negative in front of the entire function. Now when you take a negative and put it inside the function, like this, y equals f of negative x. What that's going to do is reflect it, but it's going to reflect it over the y-axis. Okay, so this is a flip over the y-axis. Okay, so let's take those original values. I'm going to just plot them real quick here. There and negative 2, 4. I think here. Okay, so here are our original coordinates, right? And let's see, we got negative 5 and 0, negative 2, negative 4, 2, negative 1, and 5, negative 1. Okay, so for this one, notice that our x has become negative. So all of our x values are going to switch signs. So this -5 of the -5, 0 is going to become +5. I'm going to do that in a different color. So this one becomes this one. -5, 0 becomes +5, 0. -2, 4 becomes +2, 4. 2, -1 becomes -2, +1. All right, and 5, -1 becomes -5, +1. And so our new graph looks like I've taken this graph and just flipped it over the y-axis. Another way to think about it is just look at it one side at a time. If I took just this piece and flipped it over, I get just this piece. If I took just this piece and flipped it over, this zinc, zinc, you'd get zinc, zinc there. Okay? So we have two different types of reflection depending on where we put the negative sign. If we put it in front of the whole function, it reflects it over the x-axis. And if we put it only in front of the variable, only in front of the x, then we are reflecting it over the y-axis, okay? So that's it for this video. Just a quickie instructional video about reflections and shifts. And so as a closing, I want to, for my own students, have you look at the top of your page, and this is the easiest math tip ever. The easiest thing you can do, or one of the most effective things you can do to be more successful in math. What does it say? Can you see it? This young man is at the vending machine looking for a math tip. He pays a nickel and he gets a math tip out that says, do your homework. All right, I'll see you next time. Bye.